Start. Good afternoon, everybody, and thank you so much for joining us in Data Science Seminar. And I'm happy to host it for the third time now, if I'm right. So it has been many years now. I still remember when I started, thanks to Jakob is here, so he was the first one who launched this seminars and in 2016, and we are still running it till now. So, and the purpose that we had behind this data science is literally to kind of bridge this gap between us and industry. And it's a place where we are communicating and getting closer and network and maybe foster some collaborations and strengthen our relationship. So I'm happy that we are still doing this seminar. I don't know if it's for good collaborations that they are coming out or maybe for the good free food. I hope not, or maybe both. But I'm so happy to be here and also to host again this seminar. So the topic of today, we're gonna, as you know, we are in this era of AI and everybody is talking about AI. And we want to push it a little bit further to dig deeper. Are we really ready for this change, or because it's already happening? And also we want to check, are we really having the foundations for moving forward with respect to integrating AI in our society, not only in industry, but also when we have it happening in education. So I'm happy to have really distinguished guests today from industry, and they're very interesting. And I think this is something that we'll explore together through their presentations. So some of the aspects that I have to point, so sorry, I have to introduce myself also. So my name is Amnir Hadachi, and I'm an associate professor here, and I'm focusing on smart city technologies. So in this climate of change that we are facing, so we have this seminar that we are trying to go into this direction of understanding the fabric behind autonomy. And especially when we are talking about integrating AI, is it just focusing on the data aspect or in the models or in pre-processing? But we are trying to not only treat each aspect separately, but as a whole into reaching this kind of real-time systems. And this is where things get really interesting and challenging. And today we have our guests that they will point out into how they experience this, especially in industry. And also we have from academia. So if I move forward to our agenda and the people that we'll have talking today. So I'm so happy that we are receiving Olena Chornovol, so the CEO of GaiaHub. And also we have Flores, so associate professor here at the Institute of Pervasive Computing. And then we have Grono, so he's lead data analyst at Veriff. And then we have Agustin, Zuniga, postdoctoral researcher at University of Helsinki, who will be joining us online. And then after that, we have Jakob, who's a research engineer at IndiGO. Unfortunately, we had a slight change in the plan, so we're expecting Sebastian Veriff to be talking on behalf of Starship, but due to some personal reason, he couldn't join us. And actually, they are good news, so no worries about that. So without further ado, I think we can move forward to our first speaker. So, please.
Hello, everyone. My name is Olena Chornovol. I'm very happy to be here and to speak on behalf of GaiaHub. We are a product company that mostly focusing on urban mobility data that help cities to become climate neutral. And today I want to walk you through the problem that we are solving and the solutions that we designed based on that, and to present the pilot solution that was successfully recently deployed in Latvia, a city Liepaja. I will also show you a little bit of our platform architecture and also prediction models that we are having in our portfolio. And also, last but not least, privacy and security, as I believe nowadays AI talk cannot happen without this topic as well. So a little bit about history in terms of GaiaHub and how we met. It happened during the Green Deal Collider course, where very powerful female happened to meet, and we all have passion in terms of climate sustainability, and we were challenged with an urban mobility topic, and we found out that almost 70% of urban pollution and greenhouse gases are generated by traffic. And when we were validating this problem, actually one of the first municipalities that we were speaking was Tartu. And Tartu shared their pain points that were mostly focused in manual reporting that they happened to have, and they needed to work within a little bit outdated data from Statistic Bureau, and it all should be collected manually, and it was based on salt patrols, which is not very precise, as the salt gasoline can be used not only in Tartu, but all over the Estonian and other countries as well. So there was an issue with getting it more quickly in an automated way. And another issue was that citizens were very disconnected from this reporting, and it was very closed, and they didn't have access to somehow contribute to positive actions towards that. So based on this idea, we came out that one of the main issues is quality of data that cities need to answer the question, like which vehicles are causing the most pollution and where. And here I presented a couple of more problems that we need to tackle using more qualitative data. For example, analyzing Eurostandard type of the cars to identify specific age groups for the cars that contribute the most to emissions generation. Another one is to explore where exactly low emission zones has to be built, and to analyze exactly the location and the car types that should be banned. As for example, even though the cars can be old, but it might be so many, like dozens of newer cars that it will not help the situation if we would ban just older cars. And another problem is to design a citywide emissions calculation, as having cameras in only a few intersections does not help to have the full picture of what is the situation now. So to tackle those issues, we designed GaiaHub Smart City platform that consists of two main interfaces. One is admin portal for municipality representatives, who can access more detailed information on the graphs in terms of the situation on the intersection, and they have access to the cameras connectivity, and most importantly, they have advanced and automated reporting that was designed specifically by European Commission standards, and it can be extracted and used for municipality needs in real time. There is also another interface which was built specifically for citizens to be engaged, and it acts as an educational platform, so they can see the situation on the road close to real time, and they can also see the activities and policies planned by municipality in order to do some positive actions towards that. So how we designed this project, I wanted to walk you through the use case of successful project we built in Liepāja. And it consisted of four main phases as data collection, data mapping, data analysis, and visualization. And before that, we also worked within the local team to prepare the low emission zone to be, and we installed cameras in two main gates of this section to monitor in and out flows of the cars. And for that, we used AI-based cameras that already had LPR, license plate recognition mechanism, embedded in that, as one of the challenges we all know Estonia is weather conditions and light conditions as well. So we needed AI calibration to that in order to have precise extract of the license plates going through this location. And we already survived the first winter with heavy snow and strong winds. So it was proven that this technology helped us to have close to 98% precise data of the cars. So once we received the recognized license plate, we save them in our cache, and we then process this information, and we do not store any image or video footage to become GDPR compliant. And once this information is saved, we do the data mapping thing, and we integrate with a national car registry database, CSDD Latvian one, to enrich this data within specific values as emission model, which Euro standard type is this car used, and which vehicle category it is, like truck or private car, fuel type, is it gasoline, electric, and so on. And already based on the first initial results, we found out that in Liepāja, it's a crazy amount of diesel cars still available on the road and driving through the city. So it was very big insight already generated by the platform. And again, to be GDPR compliant, most importantly, we do not request any personal data on the owners of the car, and it's not even allowed from API perspective to retrieve those API fields for us. And once we have this information, we do our data analysis and we apply the methodology, which is called HPFA, in order to dynamically calculate what our exact emissions are generated by this specific car in this specific moment. And beside the information, as I mentioned before, like car type or fuel type, we also add information for car velocity and acceleration in this specific moment in order to have even more precise data on how many emissions are generated by this car. So once we have the result and we have the information of the emissions generated by the cars, we have the visualization where we provide the information in specific format in the reports and dashboards on two main interfaces. So from technical perspective, I wanted to share with you the overall platform architecture, how it looks, and it has main layers starting from sensor layer. So we have cameras, and in addition to that, we also integrated API from meteorological station in Latvia to have information on the weather condition and the air quality in specific time in the city to add this to the platform information. Next layer is processing, where we used cloud-native services from Google Cloud Platform, and I will share them a little bit later in the next slide in more detail. And there is also a storage layer, which mostly focused on statistics, not on the personal information of the car owner. So we save the data, how many emissions or how many cars, which were also encrypted. So we don't know exact license plates, but just hash numbers of these vehicles. And the last layer is two front-end applications for admin portal and the citizen website. So from cloud perspective, we decided to move on with GCP, Google Cloud platform, because of their high standard security protocols and some features that are already designed to be GDPR compliant by default, by nature. And one of the most interesting ones are here in the middle. So you can see the three functions to ingest the data from cameras, to enrich them with CSDD, with Car National database, and also to process based on our methodology. And here on the bottom, there is also a service called PubSub, which allows us to store the license plates that are retrieved from cameras in the JSON format, as cameras are also connected to mobile internet. And we save the license plate in the cache of the service, and until they're used to enrich the data within this additional components from car registry. And we also have the setup of automated retention for this data, which means that the data will be automatically deleted within specific time frames that we agreed with data officer of Liepāja city. Which help us a lot to automate the whole process, and we don't need to store and manage the security and to be fully GDPR compliant within data retention part. So in addition to the problem of automating the data collection, we also now work on another problem of scaling the solution into the whole city calculation. Because even for Liepāja, which is quite a small city, it's comparing to Estonian measurements, it would be more like a Pärnu size. It's also by the sea. And even for this size, it is already 50 intersections. And to install cameras in all of the intersections, it's not very affordable for small cities, and also it's not quite sustainable. Therefore, there is a need to use AI in order to have the full picture using the real data on the spot. So now we are lucky that we already have almost a year of quality of data that we managed to aggregate from these two main gates of flow emission zone in Liepāja. And now we are working on different scenarios, how we can build this methodology to have full-scale picture of the emissions in the city. And I don't have with me our CTO, unfortunately, who has a PhD in specifically machine learning and in the urban mobility domain. So we would be happy to have any questions from you and have a talk with her together if you are interested, because we might also need to use your brains for this as well. And to summarize, as I mentioned multiple times, the GDPR and privacy is quite important topic. Just to have main tools that we use for our solution, and we would encourage you to apply them to your products as well. It is data anonymization, so we do not store in any format license plate, and we encrypt them right away. It is GDPR-compliant processing, meaning no personal information stored, like no car owners, no images, snapshots, and so on. It is secure infrastructure as a cloud-native solution and hub subservice, and data retention or data deletion protocol that should be placed based on the recommendation of data officers. So that would be from me. Thank you so much for listening, and we will be happy to share more information if you reach out on how we can make cities more climate neutral. Thank you so much.
Thank you, Olena. So now we'll take questions. Any question from the audience? Yes, we have one over there.
Thank you. So right now the cameras look at the numbered license plates, right? How easy would it be to also accommodate pedestrians or cyclists in that cameras and maybe track them as well to have a more complete picture?
Yeah, thank you for a question. I would say it would be not that easy because, for example, now we are working on a project in Pärnu, which actually has specifically these needs. We need to collect information of the cars, plus we need to collect information of bicycles, pedestrians. And for example, with our camera at the moment that we use, it is not possible to apply two different algorithms, LPR for license plate recognition and additional for pedestrians and bicycles. Therefore, unfortunately, at this moment, we'll need to use two cameras for these two purposes. But we hope in the future that there will be technology that will allow us to have these two algorithms on one camera to have it more sustainable. Yeah.
Any other question? Yes, we have one over there.
Yeah, okay, so thank you. Sorry, my voice is a bit damaged, but thank you very much. And I think it's, of course, very important stuff that you're doing. Pollution, but I have a slightly different question. All this processing of data, modeling, or what you want even to extend further the use of AI to represent what you cannot do physically. Have you any clue how much energy that consumes, or are you even interested in analyzing this energy consumption?
Yeah, it's called Javan paradox, if I know that while working on optimizing one thing, the effort that you put into optimizing is actually overused, and it's not really like optimizes in the end. So at the moment, we try to build the infrastructure as light as possible. Unfortunately, we cannot avoid it fully, and there are resources required, but we managed to use sustainability in programming as well. So our solutions, our backend application and front ends are very light. So we are not accessing the energy at this moment, and it's very lightweight from the infrastructure cost perspective as well. And these cloud native solutions help us as well a lot, like HubSub. So we don't need to store this data. It's just stored in some cache memory, and then it's automatically deleted. So yeah, at this moment, we try to do as much as we can. We cannot do like fully to eliminate all the energy, but we try to be sustainable as much as we can. Yeah, thank you.
I have a question. Hi, here. Hi, yeah. Thank you for your presentation. I wanted to ask you about the models and updating the models. So are you having sort of your training data and you're updating your models from time to time, or is it happening live given the stream of data that you keep on getting on?
Yeah, thank you. So at the moment, we haven't published yet our models. So at this moment, we are using all the historical data that we collected from the end of last year until the end of summer this year. And we are just optimizing and trying different models to see which one will bring us the best result. But in the future, for sure, we would consider having it in a stream way. So then we could have some real-time data as well coming, and then see how it will affect the situation. And it would be more already simulation, because we also work on a digital twin type of the solution for other municipality, and which is by nature requires data stream to be live in order to be to have this digital copy of the infrastructure. Therefore, for sure, we are working on that, but it is not live yet in the moment.
Right. So one last question. Yeah, please go ahead.
Okay. Thanks so much for a great presentation. Firstly, I wanted to ask, is the LPR camera data publicly available data, or do you have to make arrangements with the concrete city that you are doing this project in? And secondly, do you feel like there are enough of these cameras to make any like well-rounded conclusions, or how do you combat this problem? I understand you mentioned that you are trying to use more machine learning to combat that. Yeah.
Yeah, thank you so much. So in terms of publicity of the data, the cameras that we installed were fully owned first by GaiaHub, and then we transferred them into municipality ownership. So municipality now owns the cameras and owns the data, and we even had integration to open data portal that is available in Latvia. So they transfer their data, I believe, on a weekly basis now, but the data is not exactly the camera, because we don't save any camera data like license plate. We transfer their already processed information, how many emissions were produced, or how many like Euro Standard 6 cars were at this moment of the day at that intersection, or at all intersections. So it's already processed data only, and it's available now on this open data portal. And in terms of number of cameras, indeed we have, for this pilot project, we installed 2 cameras, but we know that in Liepāja, for example, there are 7 already LPR cameras available as well. And we have access to them as well now in order to train our model and to make it as quality as possible. We worked with municipality and transportation department in order to get access to those, to make it sustainable, because if cameras exist and there is some data, so it makes sense to utilize as much as possible. And this is what we're trying to do. And for these purposes, and for this side of the city, we believe that this would be enough at this moment. but then we will see on the quality of the results. We were also thinking on implementing mobile cameras, because cameras can be not only embedded to electricity, they can also be connected to batteries, and we can move them from intersection to intersection to have data collected for a week, for example. So then we can compare how was the model actually efficient in what we calculated and what was the actual situation. So this is what we also plan to do in the future.
Thank you.
Thank you so much, Olena. So
Yeah,
you will have
thank you so
time
much.
later to interact with our speakers during the break. Thank you.
Thank you. Thank you. Thank you. Thank you.
All right, so now we'll move from, I will say, our data ready for climate change, and we'll jump to a world where space is interacting as we design it, and I'm happy to give the floor to Huber Flores.
Yeah, all right. Does it work? It's fine? Yeah. Okay, so hello everyone. Happy to be here, and I'm happy to present some of our latest research work, which, by the way, has been kind of have a good impression in our community. But in order to understand it, you have to put a little bit of imagination from your side as well. So the topic of this talk, it's living spaces, autonomous indoor customization. And this work actually supported by the TEMTA initiative, which actually seeks to apply artificial intelligence for smart automation. So let's start by saying that, well, autonomy, right? What's the first thing that comes to our minds when we think about autonomy? We think about autonomous cars. We think about, of course, autonomous drones delivering packages here and there, or some sort of drones, right? But this is not the only place where autonomy is. Actually, we have autonomy everywhere. It's very old kind of thing. Because we spend 80% of our time indoors when compared with outdoors, there is a lot of automatic things that we have inside the buildings. Delta is a great example of that because it's a smart building. Has sensors, cameras, can measure occupancy of rooms. So for instance, if you go through the hall, you see that lights, if there is no one there, then they just will light off because you want to save energy and to reduce carbon footprint, right? And then, of course, the main goal of these technologies is that they want to optimize energy usage so that, we work effectively and we actually improve comfort and sort of productivity environment for individuals inside. But as technologies, they push forward, autonomous technologies in terms of drones and, all of this type of robots that probably you are aware of, they are coming to indoors. And they are being integrated, actually, with the technologies that we have available in smart buildings. Some of these solutions, I'm pretty sure you have seen it. I think I have seen some in airports. So then there is service robots that take you to the right way, gateway. There is, of course, these other service robots that they are also waitresses in the restaurants, and then they are providing all of these services and allowing people, to automate a bunch of tasks, right? But for the context of this talk, let's go a little bit more in the future, right? In the future, we are going to have this integration of smart building technologies and autonomous devices indoors, right? Is this actually something that it's too speculative? Actually, it is not, There is a lot of different prototypes, and robotics have advanced so much now that, there is Tesla Optimus, that it's the greatest humanoid that at some point will be indoors, helping with all of these different tasks. Even we have Stanford prototypes that are actually collecting all the objects, putting some order inside because indoors is a chaotic place. This one here in the bottom is actually from us. So basically what we are doing is that we are augmenting the capabilities of robots so that instead of just cleaning, they can do more activities because, like the more sensor data you have, the more intelligence are the models, and the more you can actually improve indoors. But one of the key problems of doing this automation is that, of course, like if you want to test them indoors, then you have to build a lot of these different devices, right? So then it's very costly. But of course, the opportunities that they are there, they are really good. One opportunity for indoor improvement is plants. Now, you might think, oh, why he's talking now about plants? Well, plants, actually, they are objects which you have seen in your offices, well, in the halls, in the receptions, everywhere. And then one does not think that much about plants, but they have a lot of benefits, of course. They improve human productivity. So, for instance, when you get your plant, from at work, it's not because they want to make it look good. Well, plants make the environments look good, but it's because there is something called the green effect. So when you look at something green, actually the cognitive load of your brain gets reduced so that you can engage with more complex tasks. But as you get exposed to this effect, then the plants are not that effective anymore. But the plants, of course, can also improve air, so CO2 reduction. They can capture noise, so you can hear that acoustics is not really good right now in the auditorium. Plants actually could help. They capture heat and improve cooling, right? But then they are there. They are just standing there. Of course, they look nice because they are aesthetic, they are appealing. But what about if we improve them with sensors? Well, there has been work about adding sensors to plants, but mostly they focus on maintenance and taking care of the plant. So then you can see some of these solutions right here. They just have smart pots where the soil and humidity is estimated so that they can tell you it's now time to water your plant. Oh, no, there is also solutions for this greenery and greenhouses so that you can cultivate plants better, more efficiently. But what about if we combine plants with autonomous technologies, right? Actually, the plants now become mobile, and we can actually harness the benefits. So imagine now a sunny day in Tartu, which there are not many, but there are. Imagine a sunny day in the summer where, for instance, in Delta, all the sun is coming inside, from the window. We have to turn on the ventilation, of course, because we want comfort. But instead of that, what we could do, we could harness the plants in the lobby or, in the halls, and just put them next to the windows automatically so that they can capture naturally the heat. And that, of course, will also reduce energy and carbon usage. But naturally, if you want to test this idea, it's not just about, building the prototype and making the plant work indoors, because when testing this technology, you have to test it at scale, because you want to see benefits at scale. You don't want to see just one plant moving around. So if you want to look at the plants in different configurations, like where they have to be located, placed, and so on, then basically you need a lot of different prototypes. And this is costly, this is difficult. But what about using simulations, digital twins? We actually, from the prototypes that we are creating in our lab, we are collecting a lot of different data from these mobile plants, and there we are transferring that to the digital environment where simulation at scale is more easier. So this approach combines two different phases. In the first phase, of course, we build a prototype, we get the plant, we integrate it with sensors, we put it in the autonomous drone. Then, at least in the case of this experiment, we actually deploy 3 different stations in 3 different offices. And these stations are actually capturing the CO2 in the room. So when there is people working and there is accumulation of people, the CO2 will rise. So the idea is that when the CO2 rises, then a mobile plant makes an intervention. So then the typical standard parts per million of CO2 that it's, in guidelines is about 1,000. And we found out that, of course, when there is more than 6 people, this goes all the way more than that, but bringing plants can help. Okay, so then this experiment was performed over a month. We collected the data. Then basically what we did is that we use co-simulation from digital twins because there is a lot of different digital twin models that we can combine. So for instance, mobility of humans, because we want to be sure that the simulation is proper and is realistic. There is as well light simulation and all of these different factors that affect indoors environments. And then, of course, we have as well the simulation of the indoor plant moving around. So by doing this, first of all, from our on-site physical experiments, we found that, of course, if you have a plant in a room and you measure CO2, you will have CO2 reduction benefits. And this depends on the type of plant that you're using. So for instance, here, you can see that this one is the most, some of the most common that they are used for indoor environments. You can see differences between the benefits of both. So if we want to analyze all of these benefits, it's even more complicated, right? Because it's not just about the autonomous technology, but it's also about the plant itself. So one of the main results was that when we have a room, and then we have, of course, a bunch of people working, and these are smart spaces, of course, offices, then you see that when we have around 5 people, we are already exceeding the amount of recommended CO2 per guidelines that should be in place to make the environment comfortable and productive for people. So then if there is no plants, of course, then you can see that this rises out to 1,700, and when we have plants, it's about 1,500. So then bringing plants and harnessing their benefits through mobility, it's important, right? So to test the simulation of our digital twins, we actually developed a simulation environment that resembles Delta building. So then this is the digital environment, and then you can see that we collected the information, we got it to our co-simulation tool, and then we then tested how the allocation of plants will be throughout of the day, throughout of the day, whether they will move to some place because they require, to capture the CO2 in a room, because mobility, of course, indoors as well fluctuates. Some of the interesting results was that at the beginning of the day, of course, when normal operations start, people come to offices, then you see that there is peaks of CO2. And then as we approach the threshold of actually not being beneficial for productivity, then plants are triggered and are introduced. And then you can see these spikes here. And as we introduce mobile plants, then you can see that all of the CO2 that was there now comes down so that we have a period of grace before we actually can turn on ventilation, right? So then there is this saving that can be done so that the indoor automation of the buildings can be on hold, and just amplifying benefits of plants can help in this matter. We found that around, of course, having 3 to 6 plants coming and going in our simulation was good enough for these indoor spaces. And then, well, I'm happy to say that at least this has been well received in our communities. Very interesting, they have said. It's unfortunately that today, actually, it's not the day tomorrow, because tomorrow we will have the notification about how this work did in PERCOM, but I'm pretty sure it did quite well. But the practicability of this work, well, people might think, oh, well, it's very difficult to have mobile plants going around, just, like moving furniture, moving plants, moving all the stuff. But is it possible? Yes, it's possible. There are implications. Yes, we need to redesign some of our, ways in which we develop the rooms. So for instance, here, if we think that we don't have a good acoustics, maybe a bunch of plants could come and then just, be around, capturing all the noise, so that the acoustic of the room will improve. But then, of course, that requires redesigning a little bit the building, improving some, perception and how these plants will move in. Of course, there is security and privacy concerns because these plants are embedded with a lot of different sensors. So if someone harnesses this potential, then can actually do a lot of surveillance. And testing autonomous technologies in large-scale deployments is quite difficult, right? But at least here, we see that we can do it with digital twins. So then we can explore different potential benefits on how to improve indoors through autonomous technologies. So, in summary, this is what we are doing right now at the lab. We are using autonomous technologies for indoor environments, amplifying benefits of plants. We are rethinking the practicability. Is it possible? To some extent, it is. But then the symbioticity between the plants and the buildings is something that, we cannot be away from greenery, right? We as humans, we have to cohabitate with green environments, and bringing automation into place can actually help to do this integration smoothly. Thank you.
Thank you, Robert. So I have a small question. It's a quick question. So I see that your prototype, it's built on the top of a vacuum cleaner robot, right?
Yeah, it's a TurtleBot robot.
So, did you measure how much cleaning did you help in Delta doing your experiment?
Well, our part of the building is quite clean, so yeah, this kept it even more cleaner.
So please, any questions from the audience?
Hey, regarding the CO2 sequestration, how much CO2 does an average person produce, and how much can a plant sequester, let's say, in an hour? And not necessarily even in numbers, but the ratio of that.
Mm-hmm. So then, at least from our experiments, if I go back to that slide, maybe I can go back to the slide. No? Ah, okay. Let me see. Yeah, so if we look at, for instance, what plants or how plants help in reduction, so one single person is not going to trigger that, much that CO2 accumulation in a space that will require an intervention of this type. When we have then spaces, now shared spaces, because offices are typically spaces which are shared, and when these offices are like with more than 2 up to 5 people, then that presents, they can raise up to, beyond 2,000 parts per million of CO2 accumulation. So then introducing the plants, depends on the type of plant, of course, can help alleviate this problem.
But here, how many hours are the people?
Yeah, these were experiments, I think 1 hour. I forgot to put that actually. But yes, so then there was periods of 1 hour where, we have a reference room, empty room, 1 hour. Then we have a person there. Then in the next hour, there was another person joining, and then we were looking at how the CO2 increases. And then we have another hour, and then we were just systematically analyzing. And then once we have this threshold of, going beyond 1,000, I think was 500, then we started to introduce the plants, and then we started to see how plants were, reducing the CO2 concentrations. So then we found out that at least the intervention starts to trigger when we have more than 3 people.
Yes, we have one question here.
Okay, yeah, thanks, Uwe. I think I still haven't understood what is your digital twin actually doing, because you're trying to model a complete system where certain different entities interact, so you must do some causal modeling, right? How do you do that? How do you figure out what are the causal relationships?
So basically, the new thing here, it's not the, let's say, the build, because there is a lot of different models for at least understanding how people move indoors, right? There is a lot of models for, as well, lighting.
Sorry for interrupting you. I mean, there must be, for the thing that you want to find out, when is the best time that the plant is being moved in or out, because I guess you want to optimize that, right?
Yeah.
But in order to do that, you need to know all the, let's call it the system of differential equations that describes this correctly. No.
You don't have to go that detail for analyzing. You can just go through simulation and approximation too.
That's what I'm talking about. I'm talking about the simulation model. Yeah.
So then, basically, all of these, the tool that we have available, let's say it's what requires is just these profiles of collected real data that depicts, for instance, let's say mobility, trajectory of, let's say the drones, how the environment is during the day, like all the different traces, and then, well, I don't know, I don't understand the...
Let's talk offline about this.
Okay. Yeah, but this is through simulation. It's nothing about differential equations.
Many simulations models in the past, and that was one of the big problems. How can you, from discrete points that you measure upfront in your rooms, how can you derive from there the system of causal relationships? I think it's not trivial. But okay, let's talk offline. But,
All right. I think we're out of time. So thank you so much for Huber.
Okay, thank you.
So I think now after checking a little bit of applications and how AI is used in different domains, I think I'm so happy that pointing out that laying down strong foundation is important, and it will be a remark coming from industry. So I'm happy that someone from industry is pointing out to education is really important. So I'm happy to introduce Eric, who will talk about laying foundations for AI, I think.
All right, so my name's Eric. I'm here from Veriff today, and I'm going to be talking about the importance of doing the basics really well before you do any of the latest and greatest fancy stuff that we all want to do. And so at Veriff, like many companies, like in academia, sometimes you do things quickly, and it's not built to last. And recently, we started a new team at Veriff called Advanced Analytics, and among other things, part of our mandate is to sort of reinforce the foundation, particularly our analytics data. That's my domain, Veriff, so that we can deploy the latest AI and ML methods on top of that. So I'll begin talking a little bit about myself. I'm Canadian. I have lived in Estonia now for almost 10 years, and my background is in physics, actually. I have a PhD in physics, where I study the Northern Lights. In preparing this presentation, I was going through my thesis and looking at all the pretty figures in it, and I chose to include a couple here, and I'll resist the temptation to talk about them. It'll just derail me, but like many, once I finished my PhD, I decided to try something else. I'd never really done anything else, so I started a data career, and I began by working a little bit in esports anti-cheat, before moving on and working at Starship for a time, and now I've been at Veriff for over 3 years. in one way or another, for most of that time, I've been trying to develop high-quality data products using our analytics stack. And the latest iteration of this is the advanced analytics team, which I'm a part of. So I imagine many, maybe most people in this room have heard about Veriff, but I will go over it in brief. So perhaps you've been asked to take a selfie, to rent a car, or to open a bank account, anything like that. And you've been asked to take a picture of your identity document, your face, and get approved. From the user's perspective, this is kind of what our journey looks like. And depending on the product, our products essentially aspire to answer 3 questions about users, and that's: who are you? Can you be trusted? And are you still the same person? So depending on the product, what the flow actually looks like varies, but this is sort of a stereotypical flow for us. Now, we use a lot of machine learning and AI techniques at Veriff. Today, I'm not really going to talk about those, but I will briefly mention them to highlight them. So, we do different things depending on which type of document it is, which type of image it is, whether it's a document or a face. Whether it's a face or document, we tend to detect whether that's in the frame. We extract data from the documents. We classify the document based off country and specimen and generation of specimen. We try and determine whether the document image was taken like live, in that moment, or whether it was pre-generated or printed out or something like that. For faces, we also test liveness, as well as assessing a person's age sometimes. There's many more things besides this. We compare the faces in the document and the selfie. We also generate risk scores and try and detect whether there's been some media injection attack going on. On top of this, we have many fun constraints like global scale, rapidly increasing volumes, real-time response time, PII in highly regulated industries, and many customers that limit how long we can even retain their data for. Now, whatever your company, whether you're in academia, you probably have a dream to employ the latest AI machine learning techniques to do something, to trivialize something that you've been struggling with for too long, or that will hopefully make you some money. Now, everyone's dreams are different, but at Veriff here in analytics, here's a few that have come up in our dreams. So, customer-facing chatbot to allow them to extract analytical insights from their data without producing workload for the analytics team. Or a verification session investigator that will help them understand why a decision was reached. Or from an internal perspective, maybe even some kind of business understander where it takes data from all different domains of the company, combines it, and can provide key insights about the forces driving change in the company. Hopefully trivializing things that would have once upon a time taken quite a lot of effort by an analyst. Whatever your dream is, it needs to come face to face with reality at some point, and sometimes reality is not pretty. Sometimes you're not actually even doing the basics very well. Maybe some of these classic memes resonate with your experience trying these things. Like maybe your data pipelines are fragile. Maybe your users don't trust you very much. Maybe you have governance issues. While there are many specific examples for these are kind of personal and relate to what your business is doing. In our case, in terms of fragility, such questions get asked as like, is your analytics platform second-class citizen compared to operational databases? Since you're not production critical, do you get adequately informed of all the changes that are coming your way? Are your data pipelines, do they have thorough enough testing? Are they built to scale? If you have, doing 1,000, new rows today and you do 1 million new rows tomorrow, what's going to happen? Do your users trust you? Do you have conflicting sources of truth? Do you have different dashboards saying different things? Have you bungled tooling migrations? And in terms of governance, who's owning different things and who's responsible for fixing things? Are your metric definitions up to date? Do you even have all the data that you need to deliver your dream? So if you want to be building things that last, then there are a number of prerequisites for success here. If you want your dream to be successful, you have to do certain things very well. Now, you need a strong foundation. Now, what does that mean? You need to be building things in a rigorous way where what was once perhaps just an inconvenience for the company could become an incident. If you have a customer-facing chatbot consuming your analytical data, and one day you wake up, all your pipelines are broken, and they've ingested some nonsense, or maybe you've gotten access to wrong customers' data, then that's a much bigger deal than when it was just an internal service. What's the state of your data products? Like, when you look at your core company dashboards, if your core company dashboards can't scale, if they're not trusted, how is your dream going to be trusted? Do you have multiple sources of truth in a single access point? Do you have single source of truth, multiple access points? The solutions for these are different. And while it may be a cliche, to build your dream, you ultimately have to walk before you can run. And recent advancements in AI and machine learning have gone a long way to commodifying this side of it, such that today the hard part of doing any of this is actually maybe even building a strong foundation. These are hardly new ideas. 10 years ago already, a very well-cited publication, Hidden Technical Debt in Machine Learning Systems, outlines that in a machine learning system is a relatively small amount of work to do the modeling, and that getting the foundation right is a massive part of it. And 10 years later, with more cutting-edge methods, people are writing the same kind of papers. So I'm not standing here today, telling a story that ends with, hey, we've got it all figured out, we've built our dream, it's great. We're relatively early on in the process, and we're in fact still building the team. Now, this is my first time being involved in hiring, and I have to admit it's much stranger than I expected. It's bizarre. It's quite challenging to hire well and be fair to everyone, and it's not obvious how weird it is when you're on the other side, when you're applying for jobs. But fortunately, I've had a partner in it who has more experience in this regard, and so far we've navigated it relatively successfully. And we found 3 key questions have been particularly useful for helping us achieve a good result. First is that, can you do a good job? Do you have the skills, or can you get the skills? Do you want to do the job? And finally, are you cool? If we have to work together every day, is that going to be enjoyable for us, or are we going to get tired of each other quickly? So, to close, I just want to reiterate that, whatever your dream is, you're going to need a strong technical foundation, strong data foundation to make it successful. And at Veriff, we are relatively early in our journey of advanced analytics journey of really trying to make our dreams a reality. And we're still hiring. If this sounds interesting to you, then maybe you want to come build with us. Now, if you're a student, then maybe you want to finish first. I know also from my own experience in academia that I don't regret finishing my PhD at all. I think it was really interesting, and I'd love to talk more about that. Or if you have experiences with the same problems that I've talked about today, I'd also like to hear about that too. So you can catch me after during the networking session. Thank you.
All right, so any questions? Yes, we have one question.
No? Okay, now. Okay, so just one quick question about, because I know Veriff, they, like focus on face recognition and all this stuff. But then, of course, like that's kind of the most, kind of say, obvious fingerprint that we have in the human body, but there are more fingerprints, and as regulations for GDPR usage of personal data, advance, and then coming out with, some other fingerprints. Do you think that face will remain as a signature, like in the long term for authentication of systems or not?
I think we're already seeing a large number of like national registries being introduced, where actually more and more we can leverage these existing registries to verify someone relatively trivially in comparison to relying on document and face. I mean, maybe there's a face image in the registry we have to compare against, but particularly regarding the documents, the registries can provide a better source of truth for that than a photo of a document.
Yeah, but like the hand, our hand is the size of the hand and the shape of the hand is already a bioindicator that can be used instead of the face, the finger joints, the fingerprints, everything. Do you think that the face will continue to dominate authentication?
I don't know. That's a good question. I haven't thought deeply about it.
All right. We have another question here.
Yeah. Okay. Yeah. Thanks for your talk. Just following up on what who I was asking. There are now these systems that recognize people based on how they walk and how they move in rooms or on the street. Is that something that Veriff is going to target also in the future? Like going way beyond like this face recognition or identification for a certain specific person for signing documents or whatever. More like in the space, in the open. So is Veriff doing something in that regard?
Veriff's, I would say Veriff's main mission is to, become the source of trust and identity online. And to that extent, I'm not sure that monitoring people's gaits to identify them necessarily fits into that vision, but maybe I just can't imagine it yet. It's not something we're working on now, as far as I know, that's for sure.
Okay, then we still have time for one additional question. All right, so maybe I'll jump in. So I have a small question. So with respect to, I will say, the application, I'm a little bit following up. So right now you're just verifying the identity. Are you having any plans to go beyond just verifying the identity? And
well, I would say that we have a suite of products, and I would say that they all in some way answer one of three questions. Okay, who are you? And that's verifying the identity. But also, can you be trusted? Like, do you have some kind of history that makes it such that one of our customers doesn't want you on their platform? And finally, are you still the same person? Extending beyond that, I don't know what the future holds, but everything that's like know your ex has probably been talked about at one point or another.
All right. Thank you very much. Big applause to Eric.
Thanks.
All right, so I think it's time to take a small break and get some refreshments, and then we will be back after in 30 minutes. And please enjoy the buffet outside. Hello again. I hope you had a good time in networking and also getting some good coffee. So the next speaker will follow a little bit in the thematic of introducing greenery in our environment, and we have Agustin. and he's from University of Helsinki. So please, Agustin, the floor is yours.
Yep. So thank you very much. Hello, everyone. My name is Agustin Zuniga. I'm postdoctoral researcher at the University of Helsinki. And well, when we talk about this autonomy, we need to think also about the sensing and how this sensing can be integrated later or to serve the AI-driven applications. So today I'm talking about smart plants for indoor monitoring ecosystems. So basically, I think that everybody knows that we have this boom of the miniaturization of the sensing of the devices, and that has driven in having some cost reduction. So we are producing more and more sensors, and in the same way, then we are having more availability and then accessibility. So in that way, we start having smart devices everywhere. But then there are some big issues related with, for example, the precision of the objects, and then also that we have many, many of them, and how to integrate this. So reducing this gap for installing indoor monitoring solution is the main idea. So, and how we do that is like integrating the sensors into a small number of objects, or minimizing the objects that where we could have that. So in this case, we could have, for example, plant containers that can be used for integrating different parts of sensors. The idea is to bring this novel solution that allow us to have multiple sensors that collect multiple information at the same time, and provide this autonomy in a better way. So as a case example, we have that the current status in the buildings, those are responsible for 30 to 40% of this global electricity consumption, which is a lot. But in many of the cases, what we have is that we just get the information about the electricity bill, but we don't really know, or we assume which are the devices that are consuming more energy. But somehow we don't know at which point, or which of them are the ones that we need to take more into account. So the problem is basically that we miss this granular information about which devices are consuming this energy. So the solution will be to have this real-time feedback that allow us to react fast enough for take decisions and reduce energy consumption. But that is just a small example case. So can we do this efficiently, which means that can we deploy some sensors, or can we deploy some AI in a non-intrusive way to figure it out that we can enhance the indoor monitoring? So then is when smart plants come into play. So when we talk about the smart plants, maybe we could think that we have some, let's say, intelligent prototypes of the plants, but in this case, it's not the plant itself, but the container of the plant. So the idea is to have multiple sensors integrated in the plant, so we could have different sensing modalities at the same time. So then, for example, we could have some moisture sensor that is used for the plant, but at the same time, this sensor will provide information about the environment. But why plant containers again? So the first thing, autonomy, it's like that we can carry the plant pot to different places. So then we can switch, and that makes the portability and the mobility. And it is also that it's easy to deploy or redeploy, so we can change, we can switch the sensors as well that we can integrate in the plant pots. That actually also eliminates to having different type of sensors. As the problem now, as I mentioned initially, is that we have more and more sensors in the market. The last reason for that is because there are some studies that have shown that the plants often offer this type of place-closed positive effects on the users. So that will help also not only for getting information about the indoor environment, but also to improve the environment itself and the well-being of the individuals. So what are the potential use of the smart plants? Are they really work, or how are they supposed to work? So this is on a study of the, I will bring two prototypes. So the prototype one, which is the very basic one, that uses environmental sensors, and that allows to measure, of course, the environmental information, to get the environmental information, but also it allows to bring new knowledge about what is happening. So, for example, in this case, what we do is we put in the container in the plant, we integrate the CO2 sensor, temperature, pressure, relative humidity. Of course, we can infer the air quality values from that. But then the question is, if we integrate that, are we measuring really what is happening in the indoors environment, or probably the plant will affect somehow these measurements? So the first thing is that we validate that all the measurements correspond or correlate similarly to the individual sensors, and we see that actually happens. The next step is testing for a different location. So as I mentioned before, we have the autonomy, so we move the plants around, which means that we can collocate them in the different places. So in the proof of concept, we showed that it's possible to have this profile of the occupancy, for example, to estimate the number of people. We can also estimate this proximity based on the CO2 concentration. So when we talk about this testing place 2 and testing place 1, then we could get this information faster. And that also provides information on how the people is located in the room itself, as well as the context that we can get from the slope, in this case, of the CO2 levels. So in this case, for example, we can see we run some tests based on the people wearing masks and people without wearing masks. So let's say that we are in the environment, so they need to make some restrictions. So in a way, we can evaluate the different phases of the curve, and then we can see how the CO2 concentration can be highly monitored when we use these smart plants prototypes. And in this case, we can even have an estimation of the amount of occupancy. This part extends for AR modeling. In this case, the modeling focus on this mass classification use and occupancy estimation that I mentioned before. And then here, what we show is that it is not really necessary to have a very long window time to get quite decent information for the classification based on the sensors that we have integrated in the smart plant. For the second prototype, we go beyond that. So we already have integrated this environmental sensing into the plant pod, but now we are moving the smart plants, integrating also thermal sensors. So why thermal sensors? So in this case, thermal sensors are important to capture other factors, like, for example, reflected thermal radiation. And in that way, we can estimate, for example, the heat areas produced by different objects. But what is the principle behind that? So then we start talking about the elements that make or that form the pot itself. So if we want to collect this type of temperature, then we need to consider also the material that is used for manufacturing the pot. And then we go into this factor of emissivity. And then it's like there are some materials that produce more reflection or this heat in a way that we can have a better estimation of the temperature that is around. So what it allows, it's that we could have a profile of the energy consumption of different devices or appliances that are around in the indoors. So then, for example, here we can see that we made some tests when you charge different devices, like, for example, a laptop and only a phone, and we see how the thermal behavior changes over time, as expected. But then here it's like, what is next? So the next thing is about combining these two information. So the information that comes first from the thermal sensors with the information that comes from the environmental sensors. So here what we can see is that combining this information provide more complete information of what is happening. And in this case, let's say if we have different appliances that are charging at the same time, then we can identify different patterns or the same patterns when we use the thermal sensing, when we compare the thermal gradients, and when also compare the different values of the environmental sensors. And this is important because in that way we can integrate the models and then we can perform multivariable analysis, which is the idea of having these AI-driven applications that participates with autonomy. So what is the next step? This is some other work that has proved in a way that if we talk about the autonomy, then we need to think on how do we plan to make these solutions intelligent in a way that can move by themselves as well. So in this case, that work showed that it is possible based on the surrounding conditions that we incorporate autonomous ground vehicles to start moving the plant. So the autonomous ground vehicles can hold the plant and then can start moving around based on the environmental conditions. So that will not only help for sensing the environment itself, but also, as I mentioned initially, that will improve the well-being and productivity that they have around the environment. So to summarize, I have introduced you the concept of a smart plant, that it's basically the idea of the vision that having this new zero configuration approach that to monitor different type of environments, in this case, indoor environments, and different applications. So in the proof of concepts that we have developed, we have tested the potential of the smart plants. The first one is using a set of air monitoring sensing for estimating occupancy and also to distinguish or verify the different human behavior. And the second thing is that we extend the initial model into with thermal arrays in order that besides detecting the environmental conditions, we can estimate the high and low consumption devices, and then we can react on the compare with using traditional power data. So this approach has the idea of having the concept of multi-sensing modalities that could allow us to emphasize a better development of a better understanding of the complexity of the environment. What would be the next steps? Of course, in this case, it will be incorporate these new autonomous mechanisms that will allow to deploy these smart plants around, and also to enhance the multivariable analysis and modeling based on the calibration to have a more different or to allow the reaction or the estimation in different contexts. So that is my presentation. Happy to answer any question. Thank you very much.
Thank you very much, Agustin. All right, so we'll take some questions. Any questions from the audience? Okay, I'll do a prop-up. So Agustin, I have a small question for you. So when you talked about measuring the emissions with respect to each plant and then you move it around, do you think there is a possibility to use this as a signature for localization? So for example, in another case, we attach these sensors to any other moving object and we can use these emissions as a way to do localization?
Yes, that is actually possible. That is the idea of have the portable sensors. So if you see, for example, from this experimental setup, that was done in a normal studio. So then here in the studio, you can see that some locations are closer, let's say, to the kitchen, and others are more located to the workspace. So in that case, then we can have this idea of localization based on the sensors, and in that it's also the important thing that it's not intrusive way of detecting. Yeah.
Okay, and with respect to your work, so is there any plans to take this, I will say, to outdoors and then have some kind of measurement? Of course, outdoors we have this kind of like fixed environment, but it's still a field that is lacking measurement also. So is the technology that you're developing for mobile indoor greenery can be also deployed for static outdoor greenery and get some measurement with respect to the emissions and also how I will say the urban space, green urban spaces are recycling, for example, the emissions and so on?
At the moment, we are focusing more in the indoor environment because if you go to outdoors, then you have different conditions, and those will be challenging. However, the principle would be the same. So the idea of having integrated the sensors, all the sensors, well, different sensors in one package in order to allow a better understanding of the environment. Yeah.
Okay. Any questions from the audience? No? All right. Thank you so much, Agustin.
Yeah, thank you.
And now I'm happy that I'm introducing Jakob, so who will take us a little bit to the autonomy fabric and literally talking about the paradigm change, especially when it comes to the autonomy of vehicles. Please.
Thank you. Hello, my name is Jakob, and I am here on behalf of IndiGO Technologies. Always thank you for having me. Always a pleasure to have a reason to come to Delta. So quick introduction, who or what is IndiGO Technologies? So IndiGO is a startup headquartered in Woburn, Massachusetts, US. So it's actually quite an international organization. The core headquarters is in the US, but we have got an EU team, mostly in Estonia, and there is also a China branch. And like the core product are these so-called flow series electric vehicles. You see two of them here, which also have a so-called smart wheel technology, which is the motor is packaged into the hub of the wheel. And as part of that, it also has some active suspension control. So these are some core technologies of IndiGO. However, there is also the autonomous driving systems branch, which I am more representing today, and I'm focusing on that side today. So besides that flow vehicle I showed you on the previous slides, there is this concept of IndiGO GoBots, which are for urban delivery making, so small, medium scale driverless delivery along the car streets alongside other cars. Some of you may know that there used to be a company called Clevon, which was born out of actually Cleveron. So the origins of that was already in 2017 in Estonia. So Cleveron is from Viljandi. And actually, IndiGO acquired Clevon in 2025. So that is where the autonomous driving competence of IndiGO has come from. And today, this branch, the Estonian branch focusing autonomous driving, is roughly 30 people, and our office is in Tartu, very close to Delta in Spark Hub. The vehicle, the platform that we are prototyping and developing our autonomy on this is the so-called Clevon 702 model. So here's a quick overview of what the capabilities of that are in terms of sensing and such. So there are 5 full HD cameras. These are like 30 FPS. There are 5 so-called 4D radars. So 4D because it's XYZ plus some velocity information from Doppler effect. There's a 4G or 5G, depends on the configuration router. And this basic this platform, you can retrofit different top applications on top of this, depending on your use case. So is it to make little deliveries of food or something else, maybe garbage? So there is a decent range on this machine. So this design is actually from the Estonian Clown side. But today, this is where the core of our research activities of developing the autonomy capabilities are happening. Could you please play the video? So just to give you an idea, we have done through the years during Clown times various pilot programs where this vehicle is being teleoperated in Tallinn, in Viljandi, in Tartu. Actually, right now also we are just in the starting phases of another pilot in collaboration with Omniva. 2 vehicles in Tallinn, I believe, 1 in Tartu. And in the bottom video, yeah, you can play that. You can see these are our teleoperator stations. So actually the teleoperation is quite a mature technology we have. It's been tested basically all over the world, in the US, in Saudi Arabia. It has proven to be quite reliable in all types of weather. But of course, teleoperation is not autonomous driving. But for some early development of this platform and kind of showing a business case, these have been useful pilots. However, let's talk about autonomy. And today, what I kind of want to talk about is, so IndiGO is in this kind of, or our team is in this kind of phase of changes due to this acquisition, but also, of course, the world of autonomy and AI, there's quick changes happening there. So what does this mean for our autonomy stack and our architecture? So here on this picture, you see the so-called conventional autonomous driving architecture. It's like quite a classic robotics architecture. On the left, you have sensing. So how do you see the world through your IMUs or radars, LiDARs, GPS, whatever. You have separate blocks for perception that do something with the sense data that tells you what is around the vehicle. There is a separate module which localizes the vehicle. Where do I exist in the world? Somewhere there is something called like a HD map, which is some mostly static information about perhaps the lane boundaries of the roads and streets, and some regulatory elements exist, perhaps already pre-baked or predefined, as this is quite static information. So these are separate modules. Perhaps there are some deep learning modules here, like a YOLO model, something like that you can imagine. Perhaps the localization is a Kalman filter, quite a very classic algorithm. You kind of bring all of these, the outputs of these algorithms together into a single world representation, something local to the vehicle's surroundings, and the conventional robotics planning algorithm will try to decide what kind of maneuver to do and hand it over to the control. So this is a brief overview of a classic autonomy stack. So this is an example from our case. So here I am visualizing on the right-hand side what our radar sees. So it's a point cloud. We have a virtually 360-degree vision of the world. This is the raw sensor data in Viljandi recent recording. Just to give you an idea of what the raw data might look like. Then perhaps your perception models will try to take that raw data and extract some geometry and some semantics out of it. So perhaps those raw data points, they become these 3D bounding boxes. There's a label attached to it, maybe a velocity vector. And this is already something then that gets passed on to the planner, who has to decide what is safe speed and safe trajectory through this world around it. And here is just an idea of, there's a separate planning module. This is like our planner simulator, this in-house tool. And my point now is that it's kind of nice when these models are separate, because yes, I can look at the planner exactly what is it doing, like why is it deciding this speed or that acceleration somewhere, and what was it perceiving from the perception side. So I can have quite a good understanding exactly. However, and here's just one more example of, could you try to play that? I think that's the video. Here is an example of a depth estimation from video. So for monocular video, on the right-hand side, a deep learning network tells you the estimated depth of every pixel, so kind of gives you a 3D representation, even though from a monocular image. So that's nice. We can inspect every single algorithm on its own and understand where it is failing. But there are problems with this approach because it tends to be quite rule-based, that the planner who is getting all this information is combined quite in a rule-based manner. So therefore, it is pretty bad at generalizing. It is actually quite nice if your operational design domain is well-defined. Maybe it's like a closed-off area, like a cargo loading zone, where you know exactly what types of vehicles are moving there. But if it's a dynamic scenario, that will not really scale. And it can be quite labor-intensive. So even though you have a good understanding of each algorithm, you have to build them up and fine-tune each of them. So you actually need a lot of engineers to make this work. You can make it work. So that kind of begs the question, and with this trend of using AI everywhere, so do we just replace everything with one big monolithic network? So basically take perception, localization, this and the planner, and in go the sensor data, and out come the controls. So is it like that? So kind of, yes, some people are basically doing that. For somebody like IndiGO, we have been building this more classic stack for years. It begs the question, so what about that existing stack? And also, can we even do that? How much data do you need, and how much compute do you need to, if you're looking for like transformer and language vision reasoning models, like is it even feasible for somebody like us? So the next parts of, and kind of the answers to these questions, I'm leaning heavily towards this recent report by AutoAware, which is influential open source autonomous driving framework and organization. So they have outlined, they're in somewhat of a similar situation, that the existing algorithms are more following this classic stack, but there is this strong trend towards more monolithic architectures. So here I'm relying a lot on that, or kind of here is a roadmap of maybe how to do it in phases. So kind of they propose that one of the first things you might look into replacing is the planner. You can keep your existing perception and localization, so out come still maybe 3D bounding boxes and velocity vectors, but the exact trajectories will be done by a deep learning model. This already helps with this generalization and avoiding too much rule-based logic. And yeah, these models exist. This is just a screenshot of there's a ton of research in this area of just learned planners who take different types of input. Is it both the radar and the camera, or some pre-processed data, or something about the localization? So this is one kind of easy step to make. Well, we can kind of continue going component by component. We can also replace the entire perception, that instead of doing some clustering of point clouds, maybe also this is some kind of a convolutional network or something like that. Again, kind of raising generalization, and also what is happening often is, as an output, if this is a neural network, you may, instead of relying on HD map, you let the perception network actually produce you this kind of a 2D map that the planner then has to work on top of. So this, if these HD maps are quite static, you have to predefine them. Instead, you can kind of dynamically come up with one from the network here. This, can you hit play again, please? So this is just an example of a network that is taking in, so this is like a learned perception that outputs a representation of the environment. So on the top left-hand side, this is the radar data, here is camera data, and out comes this 2D representation of the world. The IndiGO vehicle is green here, and there's information about the lane. So it does already look like a map, and we know the obstacles. So within this domain, the planner can then start making its decisions. But keep let's keep going, kind of scaling up the complexity. What if we basically do the whole big, huge monolith? Maybe we still want to use the HD map because it's a good prior to have. The traffic rules are static. The locations of traffic signs in this regulation is static. So just to name drop a few examples, generally the research in here or the types of architectures falls into this CNN or transformer based, which are somewhat simpler. So an example is this NVIDIA Dave 2. If you're interested, you can look it up. But now the most modern, fanciest approach is so-called taking vision language action models. So on the top is the kind of convolution network-based example. So there come, let's say, images and perhaps something about the speed of the vehicle from GPS and wheel encoders. The main component is a feature backbone that tries to bring the input into a reasonable space, and the policy model then tries to focus more on how to come up with good trajectories. This can work, can give pretty safe and working trajectories, but the issue, of course, with this type of thing is and neural networks in general. So how do you trust it? How do you know it's doing? How do you understand its reasoning? So one proposal is to become like multimodal in the architecture of the model. So take a language model also into the mix and take a larger diffusion transformer type of model. So now you not only get the predicted trajectory, but with every trajectory, if you need it, or if there's an incident later, you can also query some kind of text-based reasoning of what happened. But this also isn't just for querying later, but it is also influencing the predicted trajectory. And of course, now, I have kind of talked about then safety becomes the more you dive into that kind of AI corner, safety concerns only keep rising. Like that's the beauty of the conventional approach is I can say I understand every sub-algorithm, but with a huge monolith I cannot. So AutoWare also is outlining this need for so-called safety guardians. So kind of sitting alongside, let's say, my big learned driving monolithic neural network is another network, or maybe it might be rule-based like a conventional solution, or another network that is trying to assess that no safety boundaries are being crossed. And another way to kind of think about safety is there may be a so-called selector, that you have different neural networks, maybe even a traditional robotic stack, some models or even proprietary models. All of them propose certain trajectory, but this other module, a kind of safety gate or selector, will try to make a decision based on the current context and safety. Okay, I'm gonna skip this. So to wrap up, where IndiGO stands is, we have spent years building up this more traditional pipeline. Now we are in this mode of kind of reviewing of how can we like pivot. One thing I see is, I mentioned those safety guardians that using the existing stack as part of that safety guardian when we introduce new models seems to me a reasonable thing to do. And another reasonable use of the traditional stack is that we can use it offline to create labeled training data, because there is some object detection there. And one more comment is kind of experience that from these images, let's say we have driven a lot through the years, gathered a lot of data, but that data was not gathered with proper training in mind. So a lot of our data is, for example, the several cameras have been stitched together like this. So it is not the ideal training data. So maybe my advice is, think about training data early. Right, thanks.
Yes, we have a question here.
Thank you, Jakob. Often these guidance systems are built with a redundancy in mind, that you have multiple ones, and then when you see issues, discrepancies, then you start to figure out what is one or the other. Why don't you propose that you run both for a long while when you are doing research, especially, just to replicate the data and run both pipelines?
Yeah, actually, and also in one of those last architectural images, that was also the concept that actually...
You kind of said that this is the safeguard at the end, but you have to run it fully to understand whether you agree with the decisions or not.
Now I've lost you. That you are asking now.
That fully independent. One is fully end-to-end driving, and the other is sort of like a modular architecture. And then you see when they start to
run them side by side, and then have some decision maker after them. Based on
and observe when they are conflicting, then you can start analyzing what is the cause of conflict.
Yes, exactly. That's like I think that is the trend, or I would say like an interesting thing is like Waymo kind of maximized the traditional approach, and Tesla maximized this monolithic approach. But now I would say Tesla is taking steps. They're both like meeting in the middle, where these kind of running things in parallel and having some external decision makers make the final call.
And you and the 29 other people, how fast are you recruiting now?
You know, once a month, if you look at the past data.
Can I?
Yeah, please go.
Okay. Yeah, thanks, Jakob. Very nice and interesting. I was still wondering, in principle, what is it what tells you that you're safe enough? I mean, what kind of criteria do you use? I mean, of course, as long as you don't crash, it looks nice, but is it already safe?
Yeah, so there are these big ISO standards for safety of autonomy, but I'll bring one example that I found interesting myself in this context is generally if you have this planner who is going through the search phase of which trajectory, safe trajectory to take, also every state in that search phase should be capable of the state I'm going into. I have to be capable of making like a minimum risk maneuver of like stopping safely. Like I plan to drive there, but wherever I drive also needs to enable me to stop safely. So this is, I think, one example also that has to kind of, how do you create a loss for a model that actually takes this also into account?
Yeah, but how do you know whether in a new situation that you haven't seen before, you will still be able to handle the situation as good, at least as good as a average human driver would do?
Yeah, if it's a never before seen situation, that's a very good question. One thing that alleviates it is simulation-based training. But yeah, of course, if you see a man in a chicken costume riding a bicycle, yeah, this is a very good question, and I don't have a good answer.
All right, we have another question here. Kevin.
Hey, if I understood correctly, you were, or still are, combining your learning system with LLM in order to understand it better. But I'm not sure I follow the logic here, because surely LLM is good at coming up with explanations, but how can you trust them?
Yeah, so this is, I would say, from my perspective, more of the future vision. So today we are not hands-on working on such a model, and even Autoware is seeing this in their roadmap, I think, in 3 years, if you read that report. But the intuition is, I believe, that if you can bring your feature space has all that sensor data and it has this language-based reasoning ability, then you can kind of come up with better trajectory predictions.
And follow up this a chicken costume guy running a bicycle. What is now then programmed into the systems? What will they do if they encounter something which they really cannot process or are really uncertain which path to follow? Would they just stop? Or?
Well, I would say main example is this so-called minimum risk maneuver, that if I am uncertain about what's going on, I will try to bring myself into the least dangerous state. So maybe I will slow down a bit, maybe be ready to actually stop, get myself near the edge of the lane, etc. Yeah, but I guess it depends on the specifics. So we are also really only building this capability of also handling that.
All right, we have a question here. Given the, yeah, thank you.
I have two questions, but maybe we don't have time, so I'll start with the first. What is considered to be, safe or ideal latency between when the situation is perceived and the reaction time of the bot, and where do you have to place the compute to achieve that?
Mm-hmm. Yeah, I guess it also always, the numbers come down to how fast are you driving, right? And how fast are others driving, for example. So for our case, what we are currently targeting with this platform and the delivery use cases, we are currently looking at ourselves driving at 25 kilometers per hour, and for example, others around 50 to 60 kilometers per hour. So this means around something like a 10 hertz cycle for planning is, I think, the word like upper bound. You cannot do worse than that. Something in that ballpark. Yeah, I don't know if that answers your question.
Yeah, this is still my first question. But where do you have to? How local does the compute have to be?
Yeah, right now it's all local. So
yeah, on the car.
Yeah. Okay. For the way we are going right now. Yeah, there is no distributed aspects other than these supportive services. Maybe the HD map is there, or if there is a need for a teleoperator to take over, then these of course are external services. But the core perception planning, this is on board.
Mm-hmm. My other question was, how do you guys see your product market fit?
Sorry?
How do you guys see your product market fit?
Our product market fit?
What are you, it's very interesting technology, but like Starship, I guess, specialized in, campuses essentially, and cities to a lesser extent, but where do you guys see yourselves?
Good question. I mean, we have dabbled in different, but it's still this kind of last to medium mile delivery within urban zones. We have also dabbled with, I think one successful pilot was with Viljandi Hospital. They needed to transport, I think, some blood samples or something between two buildings between, so something like this. So relatively constrained operational design domains today. But hopefully as the autonomy capacity improves, and you can grow this domain as well. Yeah.
All right. I think there was one question. We'll take it there, and that will be the last one. Thank you.
Thank you. I have a question for safety evaluation. As you previously mentioned that currently you do use simulation, and what's the key matrix that you are using for evaluate for example, the safety, functional safety?
Well, in practice for us right now, it is more like a test scenario based approach. You define some set of behaviors, try to replicate them, vary the scenario a bit, see basically which functionality passes or not. yeah, definitely this has to be scaled up in terms of complexity.
Yeah, like the key matrix, for example.
Well, one thing is just, are you able to complete a maneuver, actually, get to the destination where you want to be? Of course, collision-free. Then if you're making a maneuver, how much are you offset from like the ideal trajectory, maybe due to control issues or something? So kind of, yeah, I don't think I have very many interesting metrics to share at this stage. It's more about kind of localization and kind of a pass-fail thing based on scenarios. And in terms of metrics, it's also like how far ahead can I make my plans, which helps me understand like how fast can I drive, right?
And do you think the current kind of matrix or the evaluation is sufficient enough to kind of confirm that the system is safe?
Good question. I mean, for us, we are like taking baby steps at a time. So we are not trying to drive across one end of Tartu to the other today. So definitely these metrics are not enough for that. But for our current use cases of more simple circuits and routes with urban routes, we are planning to have some more public autonomous routes in the next year in Tartu as well. So for that, it's I would say enough, but we are growing also this set of validation metrics.
Okay, thank you.
All right, thank you. So thank you, Jakob.
Thank you.
All right, now so we'll move to a panel discussion, and then we will open up to more questions also from the audience. All right, so I would like to thank everyone today for the presentation. It was really interesting talks. Yeah, so I will just try to follow up on some of the questions that I would think raised during this presentation. So my first question would be, introducing any kind of like AI or automation in any system. So I'm curious to see like what is the motivation, what is the challenges when you go into this direction. And one of the questions that all the time puzzles me personally, do we need AI or machine learning in every solution that we want to do? So maybe you can comment on this.
From Robin or?
maybe we'll go from industry and then to academia. Or?
Yeah. Sure, from Robin.
Okay, so where to begin? Okay, do we need it everywhere? Probably not. I mean, it's perhaps overkill in many cases. If you can do something in a simpler way that ultimately more trustworthy, then you should try that first. Maybe it's good enough. Because I think a key challenge here is, in the end, like what kind of tolerance for mistakes do you have? If in our case, if we have a customer-facing analytics tool, what tolerance for it spitting out nonsense is there? Well, we don't have the answers to this yet. I mean, to begin, we have to get to the point where we can develop these things in a way where that we've maximized the trustworthiness of the inputs to even begin to assess the quality of the outputs.
Yeah, in the domain of autonomous driving, I think like you can't look past it because this capacity to generalize is so necessary. However, I don't think you need to like too quickly think about like monolithic huge networks, but rather try to keep them isolated. That way, the validation is also more approachable. But in terms of needing like AI solutions, what has surprised me is kind of the argument that I have seen that actually you need less engineers. Of course, maybe you need more qualified engineers, but ultimately less engineers to build the AI type of solution. Of course, you need other resources like basically the data centers and the data set as well. Sorry?
The death of the junior.
Yeah, the death of the junior, maybe, hope not.
Yes, so at least from my side, I have more like different kind of opinion because I think we need AI for everything, of course. It's not that, you know, like we have this new way of decision making and inferences because, of course, overperforms traditional methods, and then you want critical systems to be implemented with the best accuracy and the best, you know, decision making. So then it's necessary. Now the problem is that this is, you know, like completely new technology. Like, you know, like there is a lot of work going on trying to understand how it works internally. We know it's probabilistic, of course, but then, you know, like how to make the decision, ensure transparency, ensure robustness, and all of these different properties that this kind of new software has. It's important. And at least from the point of, you know, self-driving, it's kind of applied and understood because there are models like, you know, like this autonomous 5-level or 6 levels driving that there is always evolving. But when you reflect back that model into like indoors, then you see that there is nothing, and you cannot map actually that same model indoors because the criticality of the system is different. Indoors is, you know, like the systems have to be very efficient and very accurate so that they can work. So the autonomy differs from what we have outdoors.
So do you think that like taking the problem from indoor to outdoor, maybe it's easier indoor than outdoor, so the outdoor dynamics are more complex? Do you think that it's wiser to master what we can do indoor before even going outdoor?
I think the complexity of indoors is it's higher because, you know, indoors it's a complex environment which always is changing. It's always in constant flux. Objects are moving, people are, you know, going around, just going from place to place. And then these systems, they need to be equipped with all of these different capabilities to sense the environment and to react in a way that doesn't disturb us. Unlike outdoor systems that, you know, like they are in the street or in a highway that, you know, like, because of course there's coverage there, you know, for positioning and so on. But then having a failure there in a highway, it's different than having a failure inside a building where potentially can be, you know, damage of infrastructure, people, and other different things. So yeah, the requirements are different, of course.
So but this is a question to all of you. So what do you think about, you see, for example, when cars, they appeared for the first time, right? And then we start having cars over. The reaction of the population at that moment, of course, I'm not from that era, but not everybody was kind of like easygoing when there is some incident. Are we in the same phase of this kind of tolerating if an accident occurs with an autonomous car? And how much tolerance are we going to have? Like, and I think we already have many cases where kind of like accidents occurred due to some autonomous car, and then the reactions, they were a little bit, I would say, some people said, yeah, it's okay. It's just when you compare the amount of casualties and then with respect to the advancement of the technology. So some people tolerated, others not. So what's your intake on this?
I think the legislation kind of has to give a bump as well, or speed or normalize things. Because yeah, in the end, are you a human driver or an autonomous vehicle? Yeah, if somebody does a completely ridiculous maneuver in front of you, you probably are not going to avoid the accident, and like maybe even laws of physics, like there's no saving you. So I think today we are at that stage where we don't even have that discussion too much. If an accident happens, like what was the behavior of the other agent? So there's usually just the focus on the fact that, oh, a robot, you know, hurt the person.
I mean, I don't work in autonomous driving, but I'm not sure what I can add that's more insightful than you, but I find it fascinating, like what does liability look like in these situations? Maybe it's already a solved problem, but I don't know. But how do you, I mean, who pays in the end? Whose insurance needs to cover, you know, a self-driving car like ramming into something at high speeds?
Yeah, so then at least for me, it's a philosophical kind of problem because it's like the trolley problem, you know. It's like you have a system which has been trained with data and is driving around, and then if something occurs, of course, who is going to be blamed with that? Of course, if you know, like if it's the human that is operating the vehicle, then it's more tolerable, let's say, for other humans to understand that. But when it's an autonomous system, that's kind of like changes, you know, the perspective.
So, do you think like let's say a project in the future? So, how long do you think that we will need in order to reach some level that we will say? Because I'm still like maybe this is my academic side. I don't believe in AI. The term really, what does it mean? Well, what I see around, it's more sophisticated, advanced machine learning models rather than AI. So what do you think, in which perspective in the future we'll have something that's really we can consider and call AI?
Well, if I think about these robo-taxi companies, I think if you're in one of these cities where Waymo operates citywide, there you are living in that future. Of course, it's not like everyday business, but it is a publicly operated service. You can, I believe, download their app and order that robotaxi and get a successful ride. So I think it is actually closer than we think, at least in some places.
Yeah, I feel like the current generation of, at least large language models, and for me, like, doesn't cross the line, and I don't think it necessarily can cross the line to be, AI in like the sci-fi sense. I think that perhaps we need to incorporate like a stronger causal understanding of the world before that box is ticked for me. But
yes, I think from, like we need to understand, of course, that machine learning, deep learning, they are, part of an ecosystem of strategies that can be used for building AI. But, building AI can be achieved with another kind of techniques, like, for instance, genetic algorithms. The problem now is that, of course, machine learning, deep learning are technologies that we can use with the resources that we have available. But as the technologies evolve, data centers become, increasingly bigger. We have more computing power. Devices becomes more powerful. Then all of these technologies potentially will converge into what it's called the superintelligence. So then, we are at the moment of AI, but we are not harnessing all the, possible strategies for building it. So then we are at the very kind of beginning, and as well. You have to remember that this is not the first AI winter. There has been so many AI winters, right? This one, of course, we passed it, and we passed it successfully because now people are investing on it.
So just to go a little bit into this direction of, so as your example, Huber, for example, and I think also Jakob, with respect to you have like an autonomous system which is running, collecting some data in real time. And also with Eric, you have the verification. So, so one of the questions that like a little bit is, I will say it's a fine line. It's this boundary between personal information and being intrusive in people's life and personal information. So how do you see to position like yourself? Like, do you feel like that the research that you're doing is kind of like crossing this line or not? Or do you have any kind of like a strategy how to keep this boundary respected?
You mean with the regulations of data collection and all
Yes,
these kind of things?
yes.
Well, at the end of the day, they are just regulations, right? And like the humans are justifying what can be collected and what cannot be collected. But to some extent, for AI systems to exist, we need data that mimics what humans are doing and whatever activities we're performing. Otherwise, they have to learn from some other ways. At least I know that there are, other types of systems that are trying to learn or make AI learn on their own. That, of course, will avoid data collection, but then that's, of course, at least with the methods, algorithms that we have right now, we need data.
I was just thinking about that. I'm somewhat happy, maybe even optimistic, that I see newer generations of things like smartphones having these, Google has this TPU, this tensor processing unit hardware embedded into them, that it gives me hope that the newer generation of neural networks can be run locally on your own device, and you're not only chained to the cloud. Sometimes I feel quite pessimistic that we're at the mercy of these huge companies of that, but I just hope that like this trend of like edge AI, or that you basically have to a degree ownership of the model, or your data only goes to the local model and you have trust that it won't leak outside of it. I think it's a crucial issue, and then so far, at least there's hope, I think.
Okay. All right. Then I don't know if there is any question from the audience. Okay, one question here.
It's a question. Oops. It's a question to Eric mainly, because for Jakob and Huber, it's very obvious where the safety criticality is. And of course, there's no safety issues in these Veriff products, but still liability. So I wonder, are there any usage or use cases or usage scenarios where somebody could sue the users of, or the custom, or your customers, or even Veriff, because some identification was done wrongly, was denied basically, or accepted incorrectly, or does this never happen?
To be honest, someone asked me about this earlier tonight too, and I can't speak to it very well, if I'm being honest. I don't think to my knowledge, we have no situations currently where we're liable. But yeah, it is an interesting, speaking more generally, I do think it's an interesting problem, especially, if your goal is to become the source of trust on the internet, then if you succeed, then there's holds a lot of power, and potentially, you end up like, if we make mistakes, people can miss out in a big way. But I think that today we don't hold so much power. We're a tool in our customers' arsenal to know their customers, and I think that in many cases, I can't think of a case where we are at risk of making such a heavy decision.
Maybe that's exactly because basically your ODD is so restricted, where also any autonomous vehicle would be safe, like these lawn mowers or so, they are quite safe, I think, because low speed, very clear area where they operate, and maybe something like is what you have. That's why. But if you would widen your application,
we have some, I guess, space from the problem in a sense. I don't know from a legal perspective, but we don't have full control over how our customers use our product and what significance they assign to our decision. We could be one of many decisions or signals they use. We could be the only one. It's not fully in our control.
All right, any other questions? Okay, so before closing, I have just a small question. Maybe this is more for Eric and Jakob. So do you think that your education, having a PhD, was worth it? Did it give you any advantage in industry?
You mind if I start? Yeah, I'm very glad I did a PhD. I know that in these days it's perhaps in vogue to poo-poo on grad school and say why bother, but I think that actually there are certain things that are really beneficial to I don't know, having any kind of data career, I guess, which are difficult to learn or difficult to like have the idea to go out and learn. Like many things are trivial to learn today, you know, learning about deploying particular models, like you have all kinds of resources, you have generative AI, many things. But what I found, one thing I found particularly useful experience in grad school, although I don't think it really clicked until later, was the process of writing and reviewing papers was really educational, and these thought processes of, you know, questioning why people are stating something, whether there's a source to back it up, and to
this critical thinking aspect.
Yeah, exactly. Similarly, needing to come prepared to back up things that you say. Mm-hmm. So yeah, I would fully encourage people to go to grad school if it interests them. I mean, for me at the time, it was the most interesting thing I could think to do, and I don't regret it for a minute.
Yeah, for sure. No regrets. I think it has been greatly useful. I was just thinking, I'll draw the funny parallel that if you're training your neural network, you scale up the input training data size, scale up maybe a number of iterations, epochs. So if you keep going, you know, to the PhD after master's, I see some similarity between those. And I was talking earlier about, oh, it's so nice to have more generalizability, or this this type of capacity that emerges from neural networks. So in my daily work, I do somehow feel that PhD has given me these meta skills that I can like jump easier between projects or actually sub problems and actually be helpful and like truly contribute to them. So
and have an impact.
I feel the PhD helped me develop those meta skills.
Great. Thank you so much. Let's upload our guest. All right, thank you very much for joining us in the seminar. It's always a pleasure to have you over. And I think we'll have our next seminar in 28th of January. And just to put the topic. Oops. Yeah, right. So and then the topic will be about AI for software engineering. And do you have the right vibe? So we are looking forward to see you again. Thank you very much. See you in the second, I would say, the next season of the data science seminar. Aitäh!